Hi there grade 9s, welcome back to WorksheetCloud Maths, and today we've got quite an exciting lesson in store for you. I hope you're going to enjoy it. We're taking it to another level. Let's have a look what it holds. Okay, so it's our 5th level in functions and relations, and we're coming to an end of this section, but let's just see what we have today. Right, so this is what you've done, just to go over where we ended last week. Well, in the last lesson rather, to see what you've done. You just go over that again. Okay, you have been able to work out a formula from a table where the x values were in sequence. Remember that right in the beginning, lesson 1. Then you've been able to use the formula to work out unknown values in the table. You were introduced to the structure y is equal to mx plus b, and then you used this to work out a formula from a table. You then used this formula to work out unknown values. You were able to work from a diagrammatic representation into a table and then work out the formula. Remember that was with the hearts and the blocks and things like that. Okay. You then learned how to graph your ordered pairs on a Cartesian plane. That's what you did the last lesson. Okay, so what's next? Seems like we've completed the whole cycle, but there's something more. Right. We're going to now, as I promised you in the last lesson, look a little bit more closely at the Cartesian plane before we go any further. So there we have the Cartesian plane. Remember I explained to you last time where there's an x-axis, which is the horizontal axis, and the y-axis, which is the vertical axis, and where they meet is the point of origin, or you can say it's the naught value. But your Cartesian plane had 4 quadrants. So first of all, as I said just now, the x-axis, which is the horizontal axis, the y-axis, which is the vertical axis, and then we've got the first quadrant, and in the first quadrant, everything is positive. The y and the x values are both positive. Okay. The second quadrant, we have the x value as being positive, but the x value is negative, as you can see on the axis, it's negative, the y value is positive. So in the first and second quadrant, both the y values here are positive, but the x value is positive in the first quadrant, and the x value is negative in the second quadrant, and you can see from the actual line itself. The third quadrant, both of them are negative, as you can see, that's negative x and negative y. And in the fourth quadrant, we've got x value being positive, but the y value this time is negative. All right, so that's the Cartesian plane. And remember, where they cross, it is the point of origin, or where they are both naught. Now we're going to look at what x and y intercepts are. And the reason we need to look at this is so we need to actually understand it going forward into the lesson. Okay, so here we've got the Cartesian plane. There we have a line graph, and what we're going to do is see where it intercepts the x-axis and where it intercepts the y-axis. So there you can see where it crosses the x-axis is the x-intercept, and where it crosses the y-axis is the y-intercept. Okay, and you can see where the two axes cross is called the origin, or the point of origin. Okay, so again, where it crosses the x-axis is the x-intercept. Where it crosses the y-axis, it is the y-intercept. And this point is going to become quite important for us. Right, let's have a look. We also chatted in the last lesson a little bit about the gradient, and I said we were going to look at that more. So if we've got a line that looks like that, just in the previous, like it looked on the previous graph, that is what we call the gradient. First of all, tells us how steep the line is and in which direction it's going. So that is by using the formula using the change of y over the change of x. And to look at the negative or positive gradient, we look at the same line and we say the gradient is positive. Okay, so the change in y over the change in x is going to give us a positive number, and that means that the graph is going to look like this. It goes from the left hand side at the bottom up towards the right. okay? Not always into the positive quadrant. It can go over here, but because of its shape going from the left at the bottom towards the right at the top, we say it has a positive gradient, right? If we look at the other one, going the other way from the right at the bottom towards the left at the top, we say that that gradient is negative, and that is when your m value is negative. So when the gradient is positive, as I said, the m value is going to be positive. When the gradient is negative, the m value is negative. So that m value tells us what the graph shape should look like. In other words, does it start bottom towards the left and then going towards the right at the top, or does it start at the bottom towards the right and go towards the left at the top? That m value is going to tell us that. Okay, and then you can always check your formula by looking at the shape of the graph, okay, or the inclination of the graph. All right, we're now going to upgrade our formula. We were using y is equal to mx plus b. We're just now going to change that b to a c, and this is y. Okay, let's have a look. So we're going to use y is equal to mx plus c. It hasn't changed much, the working of it. We've just changed the c. And that is because the c is actually the y-intercept. As I said just now, that y-intercept becomes very important. So y and x are your variables. They can change. They are in relation to one another in this formula. So when the one is one value, the other one has to have a value that corresponds, okay, depending on what m and c are. Okay, the m tells us the gradient. So if m is a negative number, we're going to know that the gradient is negative, okay, going from the right at the bottom up towards left at the top. And then the c is our y-intercept. So you can just look at the graph and you can fill in the c. Whereas before with the b, we had to put in the two ordered pairs to work out what b is. So now we've upgraded the formula. We can merely look at the graph and we can see what the c represents, what the y-intercept is. Okay, we can look at the ordered pairs to work out y and x, but also the ordered pairs would help us to work out m. Okay, the y and the x, remember, are the variables depending on which ordered pair you are looking at, and the m is the gradient. Okay, so let's look at a graph. There we have a graph. Okay, we are only working in this graph in the positive quadrant, which means where both x and y are positive. Okay, so we're going to work out the equation here. Y is equal to mx plus c. We can say y is equal to the change in y over the change in x. That's going to give us our m, and plus c is going to be our y-intercept. So look at point A and look at point B. That's going to help us with our change in y and x. Okay, we've got this one. The y value for this one is 3, and the y value for this one is 6. And the x value for this one is 3, and the x value for this one, the y value for this one is 1, and the x value is 6. And we can see where it's intercepted the y-axis is here. It is 5. Okay, so we've already got one part of our formula sorted out. It is 5 because the c represents the y-intercept. Can you see where it's intercepted? The y-axis. All right, now we're going to work out our change. As I said to you, point A, y is 3, point B, y is 1, so it'll be 3 minus 1, over the change in x, and point A, the x value is 3, and point B, the x value is 6. Okay, so we're going to put 3 minus 1 is 2, 3 minus 6 is minus 3. Okay, so our formula is y is equal to minus 2 over 3x plus 5. Okay, is this correct? This is a negative, so it should have a negative gradient. It has got a negative gradient, starting with the right at the bottom, going up towards the left. Okay, which means that we are right. Our formula is right because we can see that the graph intercepts the y-axis at 5. Right? Everybody happy so far? It's getting a little bit easier actually to work it out this way. I definitely think so. Okay, So as you can see, there's the negative gradient, there's the y-intercept. All right, let's look at another graph. Here, our line is going through 3 quadrants. We've got the positive quadrant, positive and the negative quadrant. Okay, we're going to work out the equation. We're going to say y is equal to mx plus c. Remember, the plus c is the y-intercept. Already we can see that it intercepted at 3. And we're going to work out the change in y over the change in x. Okay, just like we did just now. All right, so we're going to look at point A and we're going to look at point B. They are not the points that have been given to us. We have been given the y-intercept and the x-intercept. We don't really need the x-intercept for now. We're going to use 2 other points. So let's have a look at point A. We're going to use the y value for point A, which is 2, and the y value for point B, which is minus 2. Okay? Remember, you're going to subtract minus 2 from the 2. Then we're going to look at the x value for A, which is the bottom here. The x value for A is minus 1, minus the x value for B, which is, minus 5. Okay, there we have them. So what you're actually doing is saying 2 plus 2, because the minus times a minus is a positive. So it's 2 plus 2, and minus 1 plus 5. Can you see? Minus and minus is a positive. Okay, so 2 plus 2 will give me 4. Minus 1 plus 5 is like saying 5 minus 1. As you know, it's also going to be 4. Okay, we have got our x-intercept being 3. That's a mistake there. It's not 3. Let me just fix that very quickly for you. That's all fixed. We've now got 4 over 4x plus 3, and that will give us 4 over 4 is 1. So your formula is y is equal to 1x plus 3. As you can see, it is a positive gradient. Check it on your Cartesian plane. It goes from the bottom left up towards the top right. Okay, which means it's a positive gradient, and our y-intercept is 3. As you can see there, it's 3. Right. Everybody happy with that? Okay. Now let's look at how to work out the gradient without using the difference in y over the difference in x. Some people find this very easy. Some people prefer to do the difference in y over the difference in x, or change in y over change in x. Okay, let's look at rise and run. Okay, same graph that we just looked at. We know what the value of the gradient was. It was 1, remember? Let's have a look though at how we work out rise over run. Okay, that is the rise. From that point up to that point is the rise. Okay, it's where it touches the graph. We could even go from there up there, as long as then we go along to there. So that's the rise, and there's the run. So we would go, what is the rise? It's 3. What is the run? It's 3. 3 over 3 is 1. Okay, if you chose this point, then it would mean you would need to choose that point over there, and it would be up there and along there. Sorry, you'd keep the same point there because it needs to be the same distance apart. Okay, so you could choose 2 points and you could work out rise over run. So it's just another way to work out the gradient. Okay, let me move myself out the way. Rise over run is 3 over 3, which is equal to 1. So our m value is 1. And when we did our change, let's check that. We did all that working out and we still got to 1. Okay, remember that's the working out that we did just now when we worked change in y over change in x. So you take the rise of the graph over the run of the graph and you would end up with the same thing. You could even check it from one to the other. If you wanted to work it this way, check it against your rise over run, or if you wanted to work rise over run, check it against the change in y over the change in x. Okay. Okay, now it's your turn. I want you to look at the following graph and I want you to work out the formula from this graph. Okay, there's the graph. I want you to pause the video. I want you to work it out either with rise over run or with the change in y over the change in x. And let's see how you did. So pause the video, you do it quickly, and then we will go over it together. Right, let's have a look. y is equal to mx plus c. Let's work it out using rise over run. Okay, we're going to work it out. 1, there's your rise, 1 over 2. So that is your gradient. And where is it cutting the y-axis? It's cutting the y-axis at 0. So that is your y-intercept, your c value. So your graph, or rather your formula for your graph, is y is equal to a half x plus 0. Okay, let's check it using our change in y over our change in x. So we've now got y a minus yb over xa minus xb, which is our gradient, and then we've got plus c. Well, we know plus c is 0 because it is crossing the y-axis at 0. That is your y-intercept. So your point A is here, and your y value is 1, and your x value, sorry, that was a bit confusing. Your first y value is 1, your second y value is 0, and then your x value, the first one is 2, going across there, 2, and the second one is 0, because they are your 2 points that you are looking at. Okay, just to go over that again, because I made a mistake the first time, we're looking at y values here. What is your y value? It's 1 and 0. That point, the y value is 0, and your x value is 2 and 0. So you're going to go 1 minus 0 over 2 minus 0. You're going to get back to half x plus 0. Okay, what kind of gradient is it? It would be a positive gradient. Okay, everybody happy with that? Let's just go over it one more time. There's your formula. Using rise over run, it would be 1 over 2. There's your rise over your run, which is 1 over 2x. Your intercept is 0 because it goes right through the point of origin. Okay, if we were to use the change in y over the change in x, you take your 1 value here, which is going to be your y value here is 1, your y value here is 0, over your x value here is 2, and your x value there is 0. So it would be 2 minus 0 here. 1 minus 0 over 2 minus 0, x plus 0 for your y-intercept. You can just write that graph as y is equal to half x. Okay, there's one more for you to do, and I want you to do this on your own. Here's the graph. Okay, I want you to pause the video, and when we come back, we will go over it together. Right, let's have a look and see what you did. So we've got y is equal to mx plus c. Remember, c is your y-intercept. Where does it intercept? It intercepts down here. Let's count 1, 2, 3. Remember, it is minus 3. Okay, so as you can see, there's minus 3. We're using rise over run here. So our rise would be minus 1. Here we go, minus 1. We're going down 1. And what is our run? It would be, guys, I got a bit confused there. All right, it is going to be, our rise is going up to that point. We're going up positive 1, but we're going along minus 1 because we're going towards the minuses. Okay, we're in the minus here. So our rise is 1 and our run is minus 1. In each case, our rise is 1, our run is minus 1. Our rise is 1, our run is minus 1. So you can choose any part of the graph, and you can go, how am I getting from the one point to the other point? I'm rising 1 and I'm running 1. I'm rising 1 and I'm running 1. I'm rising 1 and I'm running 1. But each time I'm running in a negative direction. So it's 1 over minus 1x plus minus 3, because that is where the y-intercept is. So if we've got plus minus 3, it actually just becomes a minus 3 altogether. Okay, so your y is equal to minus 1, because that's what that fraction is, minus 1x minus 3, and that is what your formula is. Okay, let's use our change in y over our change in x, and we'll use these 2 points. Okay, we're going to look at where y is 1, which is here. Y is 1, can you see it's there? That's y. and where on the B, the second one is where y is minus 1. Okay, so that point and that point, 1 and minus 1, right? So there we go, 1 and minus 1. And where x is 1, 2, 3, 4, it would be minus 4, and here x is minus 2. So as you can see, it's minus 4 minus minus 2, and this is 1 minus minus 1. Okay, all sounds quite confusing, but if you look at the graph, you'll understand where we're going. All right, so here it would be 1 plus 1, because a negative and a negative is a positive. Remember, it is multiplying because it's outside the bracket. So it would be 1 plus 1. Here it's minus 4 plus 2. And remember, our our y-intercept is 3. Our y-intercept is 3. Okay, so we knew that right from the start. So therefore, we've got positive 2 over minus 2. That is going to end up giving us minus 1x plus 3. Can you see, no matter which way around you do it, you're working, you're going to get the same answer. You're going to use rise over run to get it very quickly, as long as you know how to use the rise over run. So it's from one point to the following point. Rise over run to get to the next point. If you went to 2 points up, there we go, it would be still 2 over 2, which still will give us 1. And because we're going in a negative direction along the axis negatively, on the x-axis, it would be a minus. Okay, so that would be your formula. Y is equal to minus x minus 3. Okay, this one is wrong down here. It shouldn't be a plus 3, it should be a minus 3, because y-intercept is on the minus. All right, guys, if you have any questions, this may be all a little bit more confusing than before, but actually if you work through it, it's much easier with using the y-intercept, as long as you put the right sign in, not like I did and make a mistake. If you've got any questions, please send your questions to grade 9 at WorksheetCloud.com, and somebody will get back to you with an answer. Remember to try out your activity for today, for this lesson. And there's the memo, so you can check yourself against the memo. And to change your formula to y equals mx plus c now, because c is the y-intercept. So you just look at where the line is going to cross the y-axis. Okay, and that will be your c value. Thank you for listening today. Thank you for watching the lesson today. I hope you enjoyed it, and I hope you learned more. It is quite exciting looking at graphs and trying to figure out their formulae. It's there's quite a few to do, or there's 4 to do on your activity page. Have fun with that until we get back together next time. Thank you so much for watching. Bye bye for now.